Hi, my name is Wes Overton, and I'm going to preview our lesson on factored form of quadratic functions. And one thing I highly recommend you do first is the zero product property intro activity that is in the teacher notes. That is kind of a fun activity. It actually does help students really understand the zero product property and how important that is moving forward. So once we start this lesson, we're going to introduce the idea of a zero. And one thing I do think that is important that helps is have students write zeros as ordered pairs to help them understand, that is a point on the graph where our output of the function is 0. So if I input -2, my output would be 0. Or in this case, if I input 5, my output is 0. So the zeros represent an x-coordinate and a y-coordinate, where if I input the x-coordinate, my output would be 0. So we're going to go there to explain kind of the benefit of zeros, and then the zero product property building on that opening activity, that says that if a times b equals 0, then either a has to be 0 or b has to be 0. And we start off solving equations like this, and it actually helps them make a lot more sense. So that tells me either x plus 1 can equal 0, or based on the zero product property, x minus 3 could equal 0. So then we could do some quick math. That tells me that one solution is x could be 3, another solution would be x could be -1. And I could verify that on the graph, and I see that there are two solutions. It also introduces these as linear factors, which also builds off our previous lesson, understanding that a quadratic function could be composed of a linear expression times a linear expression. So then it kind of goes on to introduce factored form as a basic introduction. And the one thing we do not talk about that first day is kind of that a value. So we could find the zeros, write our linear factors, and then kind of put that in factored form. So that kind of sets the stage for the next day, when it's going to give us three parabolas or three different functions. They all have the same zeros. So if they have the same zeros, they must have the same linear factors. Now what we notice is different is clearly, these parabolas are a little different, but also the vertexes are different. So something must account for that in the equation, and that something is going to be that a value. So what we can do is write our expression without the a value in factored form. We can pick a point besides a 0 and substitute in the x-coordinate and the y-coordinate and then solve for a. So in this instance, my y-coordinate is going to be -4. We still do not know the a value, and then we're going to substitute in -1 for my x-coordinate. Alright, and then we can do from here, we can do a little algebra to work out what that a value is. So we have -1 plus 3 is +2. -1 minus 1 is -2. And then I could have 2 times 2 is -4. I could divide by -4, divide by -4. And then the a value would be 1 in that case. So that's how we can do a little algebra to solve for the a value. If we get a fraction, we could leave it as a fraction. So next we're going to look at the different a values and how that affects the graph of the parabola in factored form. What we have here is we have two functions. Okay, they both have the same zeros, which means they have the same linear factors. And all I'm going to do is change the a value, and we're just going to look and see what happens. So now this blue one is going to be the dotted line that is going to stand still, The only thing I'm changing is the a value. As you can see, the axis of symmetry stays the same and the zeros stay the same. So we can see as that a value gets bigger, that parabola is getting skinnier, it is getting stretched vertically. As the a value gets closer to 0, it is getting compressed vertically, or is a wider parabola. And so a question is going to ask them, what do we think is going to happen if the a value is going to be negative? So that, hopefully they'll see that that'll be an opposite, which will make it concave down. So if the a value is -1, it'll be an exact reflection of a parabola with a value of +1, it'll be concave down. And it's the same idea. The further away from 0 I get, the skinnier the parabola gets, the more I stretch it vertically. The closer to 0 I get, the wider that parabola is. So I always like to give the example of vertically stretching a rubber band. So I hold up a rubber band in class, and the more I stretch it, the skinnier it gets. The more I compress it, the wider it gets. So that's looking at the graphs, and then next we're going to look at the information we can gather from an equation in factored form. And so this is a long lesson, so this might be day 3 or day 4, but now we don't have a graph. We're getting the equation and seeing what information we can gather from the equation. Well, if I'm identifying the zeros, I could use my zero product property to know that x could be -2, because -2 plus 2 makes 0, or x could be -6, because -6 plus 6 is 0. Now, you can also point students' attention to number 6 and understanding they're going to have to graph this. So as we get pieces of information, it is helpful to go ahead and put those on a graph. So we know -2, 0 is a point on the graph, and then we know -6, 0 is a point on the graph. And at this point, we're just doing a sketch of the graph, so it doesn't have to be super precise at this point. So one thing when I look at the y-intercept, a lot of students will forget, but they need to know that any y-intercept, the x-coordinate is always 0, so we could plug in or substitute in 0 for x, and that will allow us to find our y-intercept. So in this case, 0 is just a pretty easy number to work with, and it's also, so that'll be an easy point to give us. So 2 times 2 is 4, 4 times 6 is 24, so that would be the point 0, 24. I have another piece of information. I could add that to my graph. So I know up here, we're going to have a point 0, 24, which also means somewhere over here, let's see if that's 2 away, I could go to -8, 24, using that we know parabolas are symmetric. We could find the axis symmetry, so we know the axis symmetry is in the middle of the two zeros, so that must be the axis of symmetry has to be x equals -4. Once again, it's always helpful to have students write that as an equation, so they know that as a vertical line at x equals -4. They could also add the two zeros and divide by 2 to find the middle point if some of them can't see it as clearly as others. And then we can use that axis of symmetry to find the vertex, because the axis of symmetry gives us the x-coordinate of the vertex. So then we could substitute in -4 for x and then solve the equation or evaluate the expression to give us the y value. So we have -4 plus 2 is -2, -4 plus 6 is +2. If we multiply 2 times -2 times 2, that'll give us -8. So that gives us our x-coordinate and our y-coordinate of the vertex. So then we can plot that, -4, -8. And right now, that's pretty good points to at least give us a sketch of this parabola. And then we can also review the vocabulary of minimum and maximum being just the output of the function, and because this is concave up, this would have a minimum value, and that minimum value would be -8. So this is a long lesson. It does have some more problems for them to practice this, a couple exit slips they could use, but it's a very important lesson. It sets the foundation for factored form, stuff they will use throughout this the next couple units on quadratic functions.